than ever, and I've been preaching it for a long time with you guys, is that I feel like we need to start asking more questions. I feel like today is a huge day for that, especially if there's one thing that you just kind of understand but not really, make me clarify, make me slow down if I'm going too fast. Because again, a lot of your guys, when we talked about your guys' midterm, a lot of your guys' midterms, we missed questions because we didn't fully read the question, or we just missed minor details. Minor details, let's get those type of things ironed out now. This is page, 335. Thank you. Page 335. Okay. So we're just going to consider the algebra tile shown first here. We're just going to go through the algebra tile thing just to kind of get a rhythm for the pattern. But again, I'm not a huge algebra tile person. I didn't use them when I learned this. If you do like them, I can use them more, or I can help you use them more. But I feel like they're just more of a visual aid. Okay. So it says, write the polynomial expression which is represented by the algebra tiles. So what is it up here? That's 1x squared, 1, 2, 3, 4, 5, 6 x's, 1, 2, 3, 4, 8 units. So x squared plus 6x plus 8. Okay, then it says the algebra tiles can be arranged into a rectangular form as shown. So I can take 6 of my x's, 2 of my x's, my 8's right here, and then my x squared. It says write an expression of the length of the rectangle. So we'll say the length is this side. We'll say this is the width. So what does this side represent in terms of algebra tiles? X plus 4. Not x squared, because this is just the length is x. So x plus 4. The width, x, good, x plus 2, x, 1, 2. Write the area of the rectangle as a product of two binomials. So length times width, x plus 4 times x plus 2. Okay, write the area expanded, so go ahead and write it to this right here. X squared plus 6x plus 8. Okay, now let's pay attention to the patterns here. 4 times 2 is 8, right? What's 4 plus 2? 6. That's where these come. That's a sum product relationship. 4 times 2 is 8. 4 plus 2 is 6. Okay. All right, so let's go further. Okay, write a polynomial expression which is represented by the algebra tiles. Okay, so this one would be 1x squared, 1, 2, 3, 4, 5 x's, and 4 1s. Okay, it wants us to arrange them into a rectangle. So you're always going to start with the x squared in the corner here. Okay, and you can go a couple different directions, but the way I'm going to go is I'm going to go this. I have 1, 2, 3, 4, 5. Okay, and I'm about my 4 1s right here. And see, I have a perfect rectangle now. It says use results above to go ahead and factor. So what did I just, by making this rectangle, what did that form? An x plus 1, an x plus 1, 2, 3, 4. So that's kind of visual aid you could use to factor. Again, I think it's easier with the GCFs. Understanding your multiplications, it'll be easier. Any questions on the visual? Okay. Does it make sense, the area part of it? Length times width, because you're multiplying two binomials. So that's why length times width. All right. Okay. All right. I guess we have one more here. So with the algebra tiles, now they give us some negatives. So I write the polynomial expression represented by the algebra tiles. This one I'm going to have an x squared minus 1, 2, 3, 4, 5, 6. Oh, there's 7. I can't count. Thank you. Minus 7x. And how many other ones are there? 12 plus 12. Okay? So arrange these. So you have your x squared. You're going to go 1, 2, 3. 1, 2, I should go 4 on the other one, sorry. You can go either way you want. Well, I can fit 4 here. Let me try. Okay. Now, what do you notice about, what's 3 times 4? 12. Okay, it's not a coincidence. This is the way this pattern is kind of working itself out. So we have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And then all these are dark. And this is dark. Okay, so that creates a x minus 3 and an x minus 4. Just like so. Okay, all right. We're going to go ahead and just pause here just for a second. Okay, so looking on here to this investigation here, to kind of prove to you guys, we've kind of talked about it already, but just talking about where the sum product comes from. So we're going to do some examples here to expand the following. We already did some of these type of examples to start class. So just by following it out, this one we get x squared plus 6x plus 8. This one we're going to get x squared plus 3x plus 3x plus 9. Okay, I'm going to go ahead and start combining the middles now instead of doing the 2 steps like I just did on that one. So I hope that's okay with you. That's going to give me x squared plus 8x plus 7. I'll slow down a little bit so you can try. So this one foiled out is that there. Okay, this one's going to be x squared plus 7x plus 10. This one's going to be, whoops, same thing but a minus 7x. And this one's going to be like so. Okay, any questions on those, just on the foiling those out? Okay, so what I want you to do now is I want you to consider x plus p and x plus q. So consider these in the pattern of x plus p. So if I said x plus p, s plus q, in this example here, what is p? 8. What is q? Negative 6. Do you understand? So if we're looking at, this is a general, p, q. So p's 8, or q is negative 6. P is negative 5, q is negative 2. Does that understand where that pattern I'm coming from? Okay, what do you think, Xander? Get it? Yeah. Kind of? Let me know. Okay, so in each of the examples above, what is the connection between the value of b? So b, the middle, what's its relationship to p and q? So what do you notice about 2? Negative 7, 7, 8 in terms of p and q. I said factoring is a pattern of something, something. Combine them how? Starts with an S. Not simplify, no. Good try. Sum, right? A sum. Okay? The pattern, B, the middle, your middle term, every time, is these two added. What's 8 plus a negative 6? 2. What's negative 5 plus a negative 2? Negative 7. 5 plus 2, 7. 1 plus 7, 8, etc. Do you see that? So B is the sum of P and Q. So you would say this is P plus Q. What is C? C is the product of P and Q. Remember I was telling you at the beginning, factoring is the combination of sum and products, addition and multiplications. Are there any questions on that? I mean, this is very important in terms of the pattern, to understand what I'm talking about. I know it's letters, so it makes it a little confusing, but we use letters for understanding. Why do we use letters? Because this is general. This means for everything. I can't put a number that works for everything, right? I can't put 3 and 2. Okay, it's not always going to be a 3 and 2. Okay, anything else there? All right, no questions. You're scaring me. All right. Okay, so use FOIL to show. So now we're just going to prove what we were just talking about, that we can write this in this form. Okay, so this is going to look funny, but I'm going to go x times x, I get x squared. X times q, I get x, we'll put a q. P times x, I get, I'll put xp, so in the same order. P times q, I get pq. Okay? How can this is the answer I'm trying to get. I have an x squared, I have a pq. How can I make the middle look like that? What'd they do essentially? Take the x's out. Good job, Mike. So I'm going to group here. I'm going to take an x out. So it's going to be p plus q times the x. The x is going to be in the front or the back. It doesn't matter. There you go. So again, this proves the pattern. This is what? That's the B. This is the what? That's the C. That's what we just proved, just the previous slide. We proved that the end is the multiplication, the product. The middle is the addition or the sum. All right. Okay, so we're dealing with, what we're dealing with today factoring-wise, we're dealing with the concept of inspection, it's called. Inspection is factoring when you do not have an A. I mean, that is, it's the x squared, just an x squared. We'll get later in our lives here, we'll get, a 2 out front, and we'll deal with that. That's called decomp. We're going to use decomposition for that. A little bit harder. These ones are a little bit easier. Okay, so x squared only in front. Any question on that? So inspection is when this is not, or when this is a 1, excuse me. When this is a 1, because this is a 1x squared. Okay. All right. Let's change the color here. All right, so in order for factor x squared plus bx plus c by inspection, we need to find two integers which have the product equal to c, that's sum equal to b. So it's the sum product I was talking about. Okay, in order to factor x squared plus 8x plus 12, we need to find two numbers which multiply to 12 and add to 8. That's the game. Okay? That's the idea. Two numbers that multiply get 12 that add up to 8. So that's why I'm saying in your head, when you get really good at this, you'll run through 12 factors in your head. 12, 1, 6, 2, 4, 3. Which one of those add to 8? 6 and 2, right? So in order to, so that's how you would do that one. Okay, so moving on to this next one. In order to factor x squared minus 13x plus 12, we need to find two numbers that multiply to get 12 to add to negative 13. Okay? Anybody know that one? Yeah. Negative 12, negative 1. Okay? Negative 12 times a negative 1, that equals a positive 12. Negative 12 plus a negative 1, that equals a negative 13. Any question on that pattern? This is the crucial part. That's the pattern. Nothing at all yet? Okay. All right, so right here, I want you to go and take a second. I'm going to let you try these. Okay. I want you to see if you can figure out what integers work. Okay. What integers work. Okay. Allie, what did you get for this one? 4 and 5. Good. 4 plus 5 is 9. Whoops. Just the numbers. 4 plus 5 is 9. 4 times 5 is 20. Very good. Okay. Breezy, what did you get for this one? 2 and 2, right? 4 always fools people. Okay, 2 times 2 is 4. 2 plus 2 is 4. That's just a coincidence. Mike, what did you get for this one? Good. Negative 3 times negative 6 is a positive 18. Add those together to negative 19. Good. Jad, did you get this one?
No.
Not yet? Janae? This one here? Negative 14, negative 1. Okay, good. Xander, did you get this one?
Negative 3 and positive 2.
Good. Negative 3. Those are the hard ones to me. When they have different signs, it gets a little more confusing. No. Okay, good question, though. Because negative 2, what's negative 2 plus 3? It's a positive 1. So, yes, that is a good question. Good, Allie. Okay, and Josh, do you have that next one there? 5 and negative 3. Good. Okay, and Taylor, do you have the last one? Don't have it yet? Jos? Good. Negative 24 and negative 2. Negative times a negative is a positive. Add those up. Negative 26. Okay, good. Says notice. These are some I kind of like these kind of hints, things to remember. If the product is positive, the two integers must have the same sign. So what that means is that's positive. They should both be positive or both negative. Here, positive, both positive, positive, both positive, positive, both negative. So what was the difference in those? Well, that was a negative, right? So positive, positive means positive, positive. That's what I always tell my students. If you have plus, plus, it's plus, plus. If you have a plus, minus, that's minus, minus. Okay, and then everything else is just different. I mean, what that is, if this is a negative, these have to have a different sign. So whenever you have a negative sign, they have to have one's positive, one's negative. Okay, so if the product is negative, then only one integer is positive, the other is negative. Because why? Let's think about patterns of multiplication. A positive times a positive is a positive, negative times a negative is a positive. Okay, anything different, a positive negative or negative positive is going to be negative. Okay, for the remainder of the lesson, we will only deal with examples where the product is a positive. So we're going to stay with the easier ones today. Okay, these are our last examples here. I guess it wasn't too long today, not too bad. Okay, so we're going to factor the following trinomials where possible. Sometimes you can't factor them, okay? Sometimes you can't do it. So let's just do the first section together, and I'll let you guys try that second section on your own first. Okay, we'll do the top row together. I'll let you do the bottom row. Okay, so what are factors of 12 that add up to 8? 6 and 2, right? So remember, go through your head, 12, 1, 6, 2, 4, 3. This one adds up to 8. That's the one we want. X plus 6, X plus 2 is your factored answer. That's what we're talking about, from here to here. X plus 6, X plus 2. Okay, so Tatum, you know B, multiple of 12 to add up to 13. So what's multiple of 12, do you know? What's 12 plus 1? There it is. Okay, so X plus 12, X plus 1. Okay, and Brandon, what about C? Yeah, just the opposite. Negative 12, negative 1. So I'll still get you the positive 12, and that'll get you the negative 13 when you add them together. Okay, give you about 30 seconds. Try to do D, E, and F real quick. Try to do D, E, and F real quick. while you're finishing that up, I just want to show you a couple things. Okay, we'll figure out everything but the numbers. Maybe what that is that's a positive, so what does that mean? The signs are both negatives, the same. So those are both negatives there. Okay, over here, positive, positive means positive, positive, right? Over here, positive, positive. So we have all our signs figured out. So now all we have to do is figure out the numbers. Okay, so multiples of 10 add up to 11. 1, or 10, yeah, sorry. 1 and 10. Multiples of 4 that add up to 3. There is none, so we can't do this one. Okay, F. Multiples of 50 that add up to 27. Good. 25 and 2. There you go. Okay. All right, so let's finish it up here. Class example number 6. Well, now there's a number in front. Did I teach you how to do decomp yet? No. But what do you know how to do that could help you? Factor, or this one's called, what was our first lesson called? What's that? No, no. Starts with a G, ends with an F. GCF. I gave you 60%. Okay, GCF. Okay, what do they have in common here? A 4. So I can pull that 4 out. Now I have x squared minus 8x plus, what's that going to be, 12? Now factor that. Factors of 12 that add up to 8. Six and 2. Okay, so this teaches you a valuable lesson, and then Math 20 students still miss this today. They'll see stuff and they'll try to do our decomp, which is harder, without checking GCF first. Whenever you're given a factoring or a trinomial that's at the factor, always pull something out if you can. Okay, it makes your life easier. So, for example, look at B. Really ugly. A 3 and an x cubed. We haven't factored in the x cubes. But what do they all have in common? They have an x and a 3. So we can take a 3x out. You guys with me? X squared plus 7x plus 10. So what do you think, Xander? What are multiples of 10 that add up to 7? 5 and 2. See, pattern's coming to you too. We got it. Everybody's getting the pattern. Nobody's really stumped on that yet. That's good. That's the hardest part, is getting the pattern. X plus 5 times x plus 2. Okay. All right. Very good. Please do the